Eric Burgess here. We've been given the following series and they want to know, does it diverge, does it converge, and if it does, what is its sum? So looking at this, we immediately go, ooh, this is not geometric, so that's not going to be a way to deal with it. But we have a natural log here, which allows us to split this up. And when we can split things up, we have other options available to us. So let's go ahead and rewrite it in terms like this: n equal 1 to infinity of the natural log of n minus the natural log of n plus 1. And from here, we can do a telescoping series because we're going to have terms cancel because of this minus sign here. So if we go ahead and do this, we say, okay, well, we can use this sequence Sn, right, the partial sums, and we'll just write out a few so it becomes obvious what the pattern will be. So we'll have the natural log of 1, right, for the n equal 1 minus the natural log of 2. And then go ahead and put these in parentheses. And then we have plus the natural log of 2 minus the natural log of 3 plus, and then we'll do one more and then we'll write the abstract. Natural log of 3 minus the natural log of 4. And then we have plus, and then we'll have some dots, dot, 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 plus the natural log of n minus the natural log of n plus 1. All right, so just looking at this, we have things that cancel, right? This negative natural log 2 right here cancels with this positive 1. The negative natural log 3 cancels with the positive. And then this would go on and on and on forever, right? All the way up to the natural log of n. And at the end of the day, we'd be left with this and we'd be left with this. Natural log of 1 and the natural log of n plus 1. So we can rewrite the series as the natural log of 1 plus the natural log of n plus 1. And here we know that the sum of the series is equal to the limit as n goes to infinity of our sequence Sn. And if we take this limit, we're going to take the limit as n goes to infinity of the natural log of 1 plus the natural log of n plus 1. Well, if we look at this, natural log of 1 is 0, plus the natural log of n going to infinity is infinity, which is, whoops, this should be, did I write plus? This should be a negative natural log of n plus 1. It's actually not going to change our outcome, but it's good to note. That should be a minus sign. And when we do that, we're going to get 0 minus infinity. This is going to be infinity. And so we see that it diverges. So there's an example of using a telescoping series in order to sort of collapse everything down. You see how it all just kind of broke down into something more reasonable. And in this case, we were able to see that it is divergent. So this is one form that if you see something like this, you can go ahead and use this approach to find the sum and determine if it's convergent or divergent. If you have any questions, feel free to let me know, and we'll catch you in the next problem.